Today we are going to discuss about some mechanical properties, that is that compressive strength on concrete cubes, flexural strength, and splitting tensile strength of the concrete cubes. Okay, so first of all, what is mean by compressive strength? If you want to know that the strength of the concrete, as per the Indian Standard Code, the guidelines of IS 516/1959, the cube size is 150 by 150 by 150 mm is used to find out the compressive strength of the concrete cubes. So normally, if it is M25 grade of concrete, so that 25 is the characteristics compressive strength of after 28 days curing. So that curing is important here to get the strength of the concrete. So here I choose 3rd day, 7th day, and 20th day testings. So the concrete normally reached 100% strength at the after the 28th day, after the curing of 28th day. Okay. So now for a compressive strength test, the cube size is choose to 150 by 150 by 150 mm as per the guidelines of IS 516/1959. So during the time of testing, the applications, during the time of testing, the application of load works done steadily until failure was achieved. Okay, and here the rate of loading, it is important as per the Indian code, that is IS 516 guidelines. The rate of loading is 2.29 kilonewton per second or 140 kg per centimeter square per minute. Okay, so now you got the readings after the testing the concrete cubes using compression testing machine. You got the readings in kilonewton. So what is the formula for finding the compressive strength of concrete cubes? That is FCK is equal to P by A. So FCK is equal to compressive strength, unit is Newton per mm square, and P is equal to ultimate load in Newton, and A is equal to area of section mm square. So normally compressive strength, the unit value is Newton per mm square, and you are getting the test results in kilonewton. While using the compression testing machine, during the time of testing, you can receive that load in kilonewton. So you can converted kilonewton into Newton, multiply with thousands. Then P by A. So you can get the compressive strength test result value for the concrete cubes. So next one is flexural strength. So for flexural strength, normally we are using as per ASTM code. As per ASTM C7884 provision, the prism size is 100 by 100 by 500 mm is used here. So for flexural strength on concrete, I'm using as per ASTM C7884 provision, the prism size is 100 by 100 by 500 mm prism is chosen. And here 4-point loading arrangement works followed for this particular test, flexural strength test. 4-point loading arrangement works followed for this test, the flexural strength on the concrete. Okay. So during the time of loading, the load works gradually done until the failure. Okay. So during the time of loading, works done gradually until the failure. When the failure load and the point of fractures was recorded also. Okay. Then here also, as per ASTM C7884, the rate of loading was 29.43 Newton per mm square or 180 kg per minute. Okay. So then during the test, the fracture took place within the middle 1/3. Okay. Within the middle 1/3. Then only hence pure bending theory is applicable. So during the time of testing, fracture take place at the middle portion. Within the middle 1/3. Okay. Then only and hence is pure bending theory is applicable. So for finding the formula for flexural strength on concrete, That is that flexural strength is equal to PL by BD square. So here also the compressive strength unit value is Newton per mm square. The formula is PL by BD square. What is a P here? Here the P is the ultimate load in Newton. And what is a L here? Length, supported length in mm. Okay. Then what is a B here? PL by BD square. What is a B here? Breadth, width in mm. Then D is equal to depth in mm. So okay, you are getting that result in kilonewton and converted into Newton. Then that value, the data is implemented in the formula PL by BD square. You can get the flexural strength of the constant. Okay, then last one is splitting tensile strength. So here, as per ASTM C496 and also IS 516/1956, the cubes, the cylindrical specimen is used for finding the splitting tensile strength. So what is the size of the cylinder I am using here is 150 by 300 height as per the code recommendations. So the splitting tensile strength, it was done at the 150 diameter and 300 height sample as per the procedure is suggested by Indian standard IS 516 as well as ASTM C496. So here the test for this particular test, the specimen is kept in compression testing machine in horizontal position. Okay, the cylinder will be placed in the compression testing machine in horizontal position and with the packing of strips position at the both top and the bottom of the sample. So the cylinder will placed in horizontal position and the wooden strip is placed top of the specimen as well as the bottom of the specimen. Why means to allow the sample for getting uniform distribution of load. Wooden strips will be placed at the top of the specimen and bottom of the specimen in compression testing machine during the time of testing. Why means to transfer the load or to allow the load for uniform distribution to the sample. So here also code recommended the rate of loading is 0.7 kilonewton per second. Okay, as per the code. Then here the load was diametrically applied until splitting of the specimen. Okay, in splitting tensile strength, the load was diametrically applied until the splitting of the specimen is occurred. Okay, so what is a formula for splitting tensile strength? That is 2p by pi dl. So splitting tensile strength unit is Newton per square and the formula is 2p by pi dl. Here p is equal to ultimate load in Newton and d is equal to diameter of the specimen and L is equal to length of the specimen. Okay, now I show some few videos how to do the test for compression test as well as the remaining, so flexural as well as the splitting tensile strength, all those things. So this is the concrete cube kept in compression testing machine. During the time of loading, you can possible to get the cracks developed in the surface of the one of the surface of the cubes, and this is that rate of loading adjustment valve is here. So during the time of loading, you can able to view these cracks developing. Then this is the digital compressive strength testing machine, compression testing machine. So the clear view of testing cracks is visible. So here, this is a digital compression testing machine. You can able to saw that what is the ultimate load here in accurately. So after the getting the load, So after getting the result, that value you are get it in kilonewton, so that converted into Newton multiplied with 1000, then that data is implemented into the compressive strength formula, uh, law P by A. Then you can find out the compressive strength of the concrete cube. Okay. The next video is for splitting tensile strength here. So that is a 150 mm by 300 mm height cylindrical specimen is used, and you can saw here some wooden strips is kept top as well as the bottom of the specimen during the time of testing. Okay, then the load will be applied diametrically here for till the splitting will be happen to the specimen. Splitting of the specimen should be occurred. Okay, so this is a specimen in compression testing machine for doing the test for splitting tensile strength on the concrete specimen. The specimen is kept in horizontal position. So wooden strips are available, and here what is the formula for this one? 2p by pi dl. So you have to wait up to till splitting will be occurred. Okay. So for splitting tensile strength, after testing completed, that data how much load taken, that data in unit in kilonewton and converted into newton, and the formula is 2p by pi dl for splitting tensile strength, and input the data on the formula, and you can find out the splitting tensile strength of the concrete. So now the next video is for flexural strength, the concrete. As per ASTM, prism is used. What is the prism size is 100 by 100 by 500. So here for support purpose for 4-point loading, both the side 50 mm is leave for fixing the support. So both side 50 mm is marked, and you can draw the line. So the remaining portion is 400. So that 400 is divided into 3. So that is a 133 mm. So like I am dividing that 133 mm 3 portions. Okay. So see here, that is a 4-point loading arrangement is here have shown. So you can see that 3 portions I arranged, 3 portions I marked, the line is available 1, 2, 3, and we can during the time of testing, or we can get the crack in middle portion, this here. Okay, you can get it here, then only it will be pure bending theory is applicable. Okay. So then now, so after testing is over, flexural strength testing, that data input into the formula PL by BD square. You can input the data into formulas PL by BD square. Unit for flexural strength is Newton per mm square. So these are all some few mechanical properties of the concrete, that is a compressive strength and flexural strength and splitting tensile strength of the concrete. Okay.